Let's try to apply what we have learned from uniform electric field in this question over here. So the figure below shows an electron entering a uniform electric field with a horizontal speed of 1.20 times 10 to the power 7 meter per second. So you can see this is an electron over here. It's moving with a horizontal speed of 1.20 times 10 to the power 7 meter per second, moving straight line, okay, in the x dimension to the right until it enters the uniform electric field. Okay, so the whole journey from here until the moment it enters the uniform electric field, the journey here has a horizontal speed of 1.20 times 10 to the power 7 meter per second. Okay, then the parallel charge plates, which are 4 cm apart. So this parallel charge plate here has a distance of 4 cm apart, and they have a potential difference of 300 volt, 300 volt. So it means by if you take the high potential minus a low potential plate, you get that the potential difference is 300 volt. Then they say that the length of each plate is 6 cm. So if you measure the length of this plate over here, you'll find that the length is 6 cm. Okay, so yeah, this is a situation over here, and they ask you to calculate various things. One can be the time taken by the electron to traverse the electric field. They also ask for the force, the acceleration, the vertical velocity, and the displacement. Okay, to talk about this kind of situation, right, I have to emphasize that when you're solving this kind of question, try to look at it as if it's like a projectile motion question. Let me try to explain why I think of this situation here similar to a horizontal projectile actually. Okay, so in last semester, chapter 2, kinematics of linear motion, okay, in let's don't call it kinematics motion, let's call it in projectile motion. Okay, you have learned that let me give you a horizontal projectile situation where you have a cliff and you have a ball traveling with an initial velocity of u. Then after falling off the cliff, you see that the ball will trace a half of a parabolic path over here. Then yeah, this is a situation for a projectile motion. Why do I want to bring up projectile motion here is because throughout the journey here, let me draw some points here showing the path of the ball at different point of the journey. You notice that throughout the motion here, the only force acting on the ball over here is the gravitational force or the weight. There's only the weight acting on the ball over here. That's why I call projectile motion under the influence of gravity only. Okay, under the influence of gravity only. Okay, it means by throughout the whole motion over here, if you draw a free body diagram, so let me use green color to represent a free body diagram, you see that at different point along the path, the only force acting on the ball here will only be the weight, and the weight here should have a magnitude of mg, and the weight here is having a constant magnitude of force. Okay, so if your object here is experiencing a force in the constant magnitude and a constant direction, what will happen if the ball travels like this is it will follow a horizontal projectile path. This is what happened in projectile motion. Now, if you look over to this uniform electric field situation over here, what we have is usually plate, parallel plate. So let me draw it as plate positive and plate negative. Okay, so you know that there'll be electric field lines pointing from the positive plate to the negative plate. So let's just keep it simple by drawing 4 electric field lines over here. And know that if you send a charge over, okay, let's use this to represent the charge, send over a charge with an initial velocity of u. What happens when it enters the field is, okay, let's call this a positive charge. If it enters the field is, what happens is the charge will experience an electric force due to the electric field. Okay, there's an electric field, so the charge will interact with the electric field. So if this is a positive charge over here, what will happen is the direction of the force will be the same as the direction of the electric field. Therefore, you see that this charge here is experiencing an electric force pointing downwards. Okay, so if you're experiencing an electric force pointing downwards, and you know that throughout the whole motion over here, no matter how you travel in or you travel downwards, no matter how you travel, as long as you are in the region, the force that you experience should have a constant magnitude and a constant direction, because it's a uniform electric field. So the magnitude of the force experienced by the charge will be the same throughout the whole journey. The direction of the force experienced by the charge will be the same throughout the whole journey. So it's a very similar situation to the horizontal projectile motion just now. Because the only force acting on it is the weight, and the weight has constant magnitude and direction, you see that the object over here will trace out a parabolic path. Same situation over here, the only force acting on the charge here is the electric force, the Coulomb force, and it's acting with a constant magnitude and direction throughout the whole journey. Therefore, you should expect that the charge should follow a path which is parabolic as well. So this will be the path traced by the charge when it moves in the uniform electric field. And throughout the journey, again, I'd like to emphasize that at any point you see that the the electric force should be pointing in the same direction, and it should have the same magnitude. Okay. Next, you still remember that from projectile motion, let's go back to projectile motion. You remember that AY it's always negative 9.81 meter per second. Okay, or in another words, it's equals to negative g. So actually, how do you get this AY actually? It comes from F equals to sum of Fy. What am I writing? It actually comes from sum of Fy equals to MAY. Because net force causes an acceleration. This is what happened that causes the acceleration for projectile motion. The sum of force acting in the y dimension is equal to the mass times the acceleration in the y direction. So in this situation here, the only force acting on the object in the y direction is the weight. And since the weight is pointing downwards, then therefore you get a negative mg. Okay, because the weight is pointing downwards, we define downwards as the negative y direction. That's why it's negative mg is equals to may. So if you cancel the m, then you get that ay is equals to negative g. That is what happened actually when you're doing semester 1 kinematics of linear motion, to be more specific, projectile motion. Now in uniform electric field, if we do the sum of Fy is equals to may, you'll find that the only force acting on the charge over here will be equals to negative of force electric. Okay, force electric, it's a magnitude, it will be a positive value, but you attach a negative because it's pointing downward. Okay, then it's equals to may. Okay, so this one, how do you find the electric force acting on the charge? Well, you know that it's just Q times E, where Q is this charge over here, then E is the magnitude of the uniform electric field in between the two plates. Then you get MAY. So AY will be equals to negative QE over M. Okay, I would like to emphasize that this is absolute value of charge. Okay, this is what you learned from last time. Force is equals to absolute value of Q times E. Okay, so everything here should be a positive value. You attach this negative here because this acceleration is pointing downwards, same direction with the force. Okay, but if today we switch the plate over here, if we switch the plate, let's say I use orange, say I switch it to a negative plate over here and it's a positive plate over here, then the direction of the electric field will be pointing upwards. In that case, the force experienced by the charge will be pointing upwards. So what happened is the charge will be moving in a parabolic path upwards instead. Okay, now the force is pointing upwards, so the parabolic path will be upwards. Okay, so you can see that the positive charge is being attracted to the negative plate. Just like what we know, positive and negative attract. Previously, if it's a positive and a negative plate over here, you see that the positive charge will move towards the negative plate. Okay, the charge always move towards the plate of the opposite sign. If it's an electron, you move towards the positive plate. If it's a positive charge, you move towards the negative plate. Okay, so we know that the F electric will be constant throughout the path. So if it's the orange situation, then your sum of Fy will be equals to MAY. Then it will be F elect. The electric force is now pointing in the positive direction, so you don't need to include a negative sign here anymore. And it will be equals to MAY. So now you can do Q times E is equals to MAY. Therefore, AY is equals to the absolute value of charge multiplied by the electric field divided by the mass over here. So there is no fixed formula for the acceleration actually. You have to look at the situation to determine whether the acceleration is pointing in the positive y direction or negative y direction. Or sometimes they might even have plates which are arranged in this arrangement instead. Okay, you still can have plates that works like this also. So if this is a positive plate, this is a negative plate, then your electric field will be pointing in this direction instead, to the right. Okay, so in that case, if you are sending a negative charge, let's say if you are sending a negative charge into the uniform electric field, then you get attracted to the positive plate. You know, you move like this because the force experienced by the charge at various points, okay, it's a negative charge, the force will be opposite the direction of the field. The field is pointing to the right, therefore the force experienced by the electron will be pointing to the left. Therefore this one will be F elect will be pointing this way, F elect will be pointing this way, F elect will be pointing this way. So in that case, if you proceed to do your working, it will be sum of Fx instead of sum of Fy right now. So it will be MAX. Then this time it's going to the left. Left you treat as negative, so it will be negative F elect. Then this one will be equals to MAX. And this one will be negative Q times E equals to MAX. Then you get that AX is equals to negative of absolute value of Q times E divided by the mass of the negative charge over here. Okay, so you have to react to the situation in order to determine the expression for acceleration. For force, it's always Q times E. That one is quite fixed, but for the acceleration, you have to react to the situation. F is usually the magnitude. That's why we usually come up with a positive answer. Okay, so let's try and get into this question over here and try to see how this whole thing works. Okay,